Welcome back, everyone. So this is the third of 4 examples on on modeling using exponential functions, and this is another one related to money and investing in the stock market. Okay, so usually when people talk about how fast stocks grow, they give a percentage, like an annual growth. And so suppose you have a certain portfolio that grows at 7% each year. And if its value was, let's say, $1 million in 2006, we'd like to find out, well, how much would it be worth today? But more generally, let's find a formula for its value. That is, if P of T represents the value of the portfolio T years after 2006, that is T years maybe when it was after it was invested, what's the formula for P of T? Okay, so if something grows at 7% a year, that's the same thing as saying that it's multiplied by 1.07. Okay. So in the previous example, things were being multiplied by 2 every 6 years. In this example, we're being multiplied by 1.07 every year. And that, in a way, is going to make things a little easier, because then P of T, well, we can still say that P of T is in the form of A times B to the T, where P of 0 would be 1 million, okay, and then P of 1 would be 1 million times 1.07. We won't worry about what that is right now, but basically you can see what the formula will be is that P of T is going to be 1 million times 1.07 raised to the T power. Okay, so all right, now this is, of course, since it's dollars, you want to read the problem very carefully, because sometimes they might say, let P of T be the value in millions, in which case it would just be 1.07 raised to the T. Well, once we have that, then things are very straightforward, right? Because when T equals 2007 is exactly 1 year from 2006, right? So this would just be 1.07 times a million, which is way up here. It is up here. Okay. 2008, that corresponds to T equals 2. So this would be 1.07 squared times a million. Okay, or that turns out to be 1.1449 million. Okay. When 2009, that corresponds to T equals 3. So this would be 1.07 cubed, which is, well, it's not equal, I'll just say it's 1.225 million. I'm just reading this because you can do this on your calculator, include all the digits. Okay, but I'll just write in terms of a million. 2015, that's 9 years since 2006. So this would be 1.07 to the 9th, and that would be 1.838 million. 2020, that would be 14 years from 2006. So we take 1.07 to the 14th, and that is 2.579 million. And then 2024, that's 18 years from 2006. We take 1.07 to the 18th, and that gives us 3.380 million. Okay, so 18 years can go by real quick. The older you get, and you can make quite a bit of of money. If you're lucky enough to be in the stock market that averages 7% each year, it's not quite that. It hasn't been quite that good, but it's the last couple decades has been very good, especially the last decade. Okay. And of course, the downside is, of course, that your capital, in this case, your capital gains would be 2.38 million, and that would be taxed at a certain rate. So you got to figure that in. But still, if things grow exponentially, that's very, very good. Okay, the last example here. Now we're going to go in the other direction and talk about something that decreases exponentially, like a radioactive element. And when you talk about how rapidly an element decays in chemistry, you talk about in terms of half-life. And that's the amount of time it takes for it to decrease to half its size. So, and we're saying everything decays exponentially. So, in this case, in this example, a certain radioactive element has a half-life of 900 years. And if we let R of t be the percentage of the element remaining after t years, I'd like to first find the formula for R of t. Okay, so knowing that elements like this decay exponentially, we know that R of t will fit the exponential model. Okay, and we're going to see right now that R of t was a percentage, so we're going to assume that R of t is a number between 0 and 100 to make things easier. And we know that obviously when we start out, we have 100% remaining, and 900 years later, we have 50% remaining. So we have these two things, and now we're going to just find what A and B are and go from there. So, so when t equals 0, we have 100 is equal to A times B to the 0. And when t equals 900, 50 is equal to A times B to the 900. And from this equation we get 100 is A times 1, so A is 100. And then from here we get that 50 is equal to 100 times B to the 900th power. We can divide both sides by 100. And this reduces to 1/2, and this is just B to the 900. And once again, we need to take, well, in this case, we take the 900th root of 1/2. We can do that just by raising both sides to 1 over 900. Okay, and again, you have to do that on your calculator. Okay, so you'd have plug in 0.5 and then raise it to 1 over 900. And when you do that, it turns out that 1/2 to the 1 over 900 on your calculator is approximately 0.9992. So that's what B is. Okay, so we get that R of t is 100 times 0.9992 to the 10th power. Okay, and you really want to get this, take as many digits as you can. Okay, in this case. So the question is, what percentage remains after 100 years? Well, you plug in t equal 100, and you get 100 times 0.9992 to the 100th power. Okay, and this turns out to be approximately 92.3%. Okay, and then if you want to see what percentage remains after 1,000 years, you just plug in t equals 1,000, and you get 100 times 0.9992 raised to the 1,000th power, and that's approximately 44.9%. All right. All right. Well, that's basically how you do this using your calculator. Remember, take plenty of digits. The more digits you take, the more accurate you'll be. And go ahead and try work on the homework problems, and I'll see you next time.